আমি পাতলা হয়েছে কিনা বলো।
ওইটা প্যাকেটে না এই দুধগুলো ফ্রিজে রেখে দিস। হুম।
ভাবো কোনটা করে আবার আচ্ছা দেখি তারপর হয়ে গেছে কি কচকচ করে কাঠের পাছা নিয়ে ঘুরছে আরো সবাই দেখি তুমি পাচ্ছে না বলে কি জাগে ধরে নে যদি ভালো লেগেছে তো ঠিক আছে হ্যাঁ ভাবো সব নোংরা ছেলে বলার কেটে যাবে সেসব ভাবি কি হয়েছে অনলাইন থাকলে মানুষ বাড়াই
আমি এখানে রেকর্ড করছি।
তুই রেকর্ড করেছিস আমাকে দিয়ে দিস আমাদের কথা হুম 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 আর এটা ছোড়া হুম তাদের ছোড়া টাইট মুভমেন্ট করা নিয়ে দেখবি বাবা এগুলোটা আমার থেকেও বেশি আবার মানে বাসায় বাসায় জলেও খা কি নাটক এখন দেখবে ঘড়ির কাঁটার দিয়ে খালি মন কখন ডোমটার দিকে যাবে হাঁটাগুলোর মতো খালি যাবে দেখে যাবে আরে আমরা দিয়ে তো দিন কাটছে না তাই তো আমাদের বাড়িতে এগুলো পাঠাতে হয়ে যায় একটু কাজকর্ম করতে হয়ে যায় হারানোর পছন্দ বার বানানো হয় তাই ছোটবেলা থেকে বাচ্চাদেরকে মেরে মেরে মানুষ করছে আদর করে আমাদের আদর্শ মতন হয় না দেখবে তুই আমি আমাদের ডেইলি আমলের সাতটা হচ্ছে কিনা বলো সাতটা হয়েছে কিনা হুম জলেনটা এসে গেছে দেখো এখন কাজ হয়ে হয়ে দেখছি কখন খেতে পারবে দুই সব থেকে নজর তেল ভালো বাটার সব খাবো মেয়ে তো বাবা তো সহ্য করে খাচ্ছিস কেন দেখে নেওয়ার পর খাবি না তাড়াতাড়ি তোর স্টুডেন্টদের সাথে তুই খাবি সব নোংরা ছিল সেখানে আমার কপালে একটা এবং দ্বিতীয় একটা দেখা যাচ্ছে নেবে চাবি নেও নি আচ্ছা দাঁড়া আমি আসছি আমি
এটাকে একটু ওইগুলোকে ফ্রিজে রেখে দিস।
কেন বেরিয়ে যাচ্ছ আমাদের সাথে ছবি তোলা তোমার কাছে খালি ঝগড়া হয় তোমার কাছে
Okay, we will be starting our session in about 3-4 minutes more. We will wait for others to join and then start discussing the questions.
এগুলো খালি ফেলে দিই
Okay, fine. So we will start our session now. I will start by introducing today's live session, that is week 7 of Integrated Waste Management for a Smart City. And I am the TA allotted to this course. And as per my introduction, I am currently pursuing my PhD from IIT Kharagpur under the supervision of Professor Pradesh Kumar Dubey and Professor Makaran Madhav Gandhikar. So just like other live sessions, today we are having 15 number of questions, all of which are MCQ, and there are few numericals, about 3-4 numericals are there, and rest are very simple but conceptual solid waste management based theoretical questions. So we will start with question number 1. So you have to choose an option wherein, which is a thermal conversion technique, wherein the gas is superheated to an ionized state. And your options are combustion, pyrolysis, gasification, and plasma. Okay, fine. So I will, for this particular question, the correct answer was plasma arc, and I will discuss these individual processes as well. Like combustion, most of us have known from very early days that combustion is basically burning of a material in the presence of oxygen. So that is combustion, or like there is oxygen rich and oxidative environment exists when combustion takes place. Pyrolysis typically takes place in an inert atmosphere. That inert atmosphere is created by flowing nitrogen over a heated material, or flowing any other inert gases like helium, argon, such noble gases. So those kind of high temperature activities under inert atmosphere, they are often called as pyrolysis. Gasification is not complete combustion or complete combustion, or in the sense that there is a partial oxidation kind of situation in here, partially oxidative environment. So under those circumstances, gasification takes place. It is somewhere in between pyrolysis and combustion. But plasma arc, it is a very, very, very high temperature, above 5000 degrees centigrade, or in fact about 10,000 degree also it can go. Such high temperatures are there wherein whatever material you are subjecting under plasma arc, it will mineralize, not only mineralize, it will ionize to the very basic levels because of its very high temperature. So technically speaking, you put in any contaminant, any raw material, it will completely ionize it. But on the downside, why we don't use such techniques? Because they are very, very energy intensive, and sometimes it doesn't make sense to go for plasma arc for any kind of waste management technologies or approaches. For certain specific instances, one may choose to go for plasma arc. So this was question number one. Then moving on to question number two. Okay. So you have to choose an option wherein acidogenesis and methanogenesis, which are components of anaerobic digestion, they take place separately. Yes, option 2 is the correct answer, wherein hydrolysis and acidogenesis, they take place in the first tank. Mostly the first tank is often under mixing, and the dome which is there above that tank, it is also fixed because this methane generation is not the primary goal of that. Then in second tank, methanogenesis takes place, so its dome above that tank, it is often flexible because the gas can be stored above the liquid or that supernatant level. So that is where methanogenesis takes place, and methogens can also perform better because they are not getting mixed up with acidogens. Because if acidogens produce acids, and if it crosses or moves beyond this neutral range, then methanogens, their performance gets really degraded, and methane release also becomes very, very less. So that is why it is often beneficial to operate these two, methanogenesis and acidogenesis, in two separate tanks. Let's see if we have anything else. Okay, yeah. So relating to the previous question, I will just add a couple of more points. So here you can see that gasification is nothing but partial combustion, and plasma, just like I said, it completely ionizes the material, that is by breaking the chemical bonds. And there is an like gasification can be of different types and different purposes. The main target of gasification, though, it is to produce gas which is having some energy value, like syngas or hydrogen rich gas. Those are often the products of gasification. And then gasification can be of various kinds, like there are like supercritical water gasification is another process that is typically used to produce syngas or increase hydrogen content in the gas. In supercritical gasification, what happens? Supercritical water gasification means like the feedstock, it is in aqueous phase, there can be some solids, but the conditions, the temperatures of the water, they are in supercritical state. And supercritical state means The temperature should be above 373 degrees centigrade and pressure above 220 bars. So what happens under those circumstances is that water behaves like a organic material, like a non-polar solvent. Usually, water is a polar material. It acts as a polar solvent, but under supercritical conditions, it becomes a non-polar solvent. Behaves like that. So that is like one of the types of gasification. Then CO2 gasification is another kind. Pyrolysis, as I have said, it takes place in the absence of oxygen, and pyrolysis, the main products of pyrolysis can be char, pyrolysis oil, and then the gas. It can also have significant calorific value based on its combustion, based on its composition. For example, by employing different kinds of catalysts during pyrolysis, we can increase the methane or in fact the hydrogen content in the pyrolysis gas, thereby increasing its fuel value. So main products of pyrolysis, they can be char, the the bio oil or pyrolysis oil to be more specific, and then the pyrolysis gas. So pyrolysis can be also of various types. There can be slow pyrolysis, intermediate pyrolysis, fast pyrolysis, or in fact, there is another instant pyrolysis or very fast pyrolysis, something like that. So these rates of pyrolysis or the type of pyrolysis, it depends upon the heating rate. And then combustion, so like it takes place in a complete oxidative environment, which include incineration, cogeneration, most of the energy from waste processes. So that was like it. And then this is about the anaerobic digestion, the two-stage anaerobic digestion, wherein the first stage, where acidogens along with hydrolysis lysing bacteria, they are also present, whereas in stage 2, methogens live. Now moving on to the next question.
Excuse me, sir. Can you ask one question regarding pyrolysis? And pyrolysis
Yeah,
is a combustion process, it's a thermal process. And you are telling it is done in the absence of oxygen, then how combustion takes place without
Uh,
oxygen?
actually, combustion and pyrolysis are completely different. When I am saying that a material is being combusted, but like by definition, combustion means that there is a presence of oxygen, an abundant amount of oxygen. That is why combustion is taking place. Basically, if there is a carbon material, C is reacting with O2 to form CO2, and maybe if there is incomplete combustion, then some CO may be formed. So if there is no oxygen, then we won't tell that process as combustion. It will be a pyrolysis under those cases or some other specific processes if something else is taking place. Like combustion is particularly only under oxidative conditions. But if you want to say it like pyrolysis, then you will the right way to say that I am exposing a material under high temperatures under inert atmosphere. So thermal exposure under inert atmosphere, that can be the correct way to like briefly tell about pyrolysis. Like we can't say that pyrolysis is combustion under inert atmosphere, because combustion itself means that oxygen is present. That is why it is burning.
Okay, if I rephrase my sentence, that
Hmm.
pyrolysis is a process in which uh, fire is taking place. Means we are cleaning something in the absence of oxygen. So
Ah,
how
so what happens is that, for example, if
burning?
there is like a material, it can have, I will show you here, a material, it can have carbon, hydrogen, nitrogen, sulfur, and many other stuff. So what happens is that if you are combusting anything, so that you know that C plus O2 plus CO2 will be formed. But in case if it is taking place in an inert atmosphere, so what will happen? I will give you an example. Then first, so if you look at it from the perspective of its thermal performance, a material is first characterized by based on its proximate analysis, wherein we see its fixed carbon content, then how much volatile matter it has, then ash, then moisture content. So what happens, like in case if you're heating a certain material, it may let it be wood or anything. So what happens is that if you heat it under pyrolyzing conditions, then that most of the carbon that is present in there, it won't go away, like most of it. But rather what would happen is that there can be some volatile materials which are having very less like evaporation or very less vapor pressure, components will be formed, because in those cases what will happen, oxygen won't be reacting, but the energy that is present there, heat energy, it will go in and break certain bonds which are present in that macromolecule. So based on the kind of bonds that is broken, so for example, let's say this C6H4, this is, let's say, a benzene in between, benzene aromatic structure. So what will happen, like if there is oxidative environment, then the CO2 will be formed most probably if there is complete oxidation. But in case when I am pyrolyzing it, then the heat energy that I am supplying, it will typically be spent by for breaking these bonds, the easier bonds. Like the bonds can be broken from here. So see, methane can be formed. So methane is a volatile matter, so that is why it comes under this volatile fraction. So if methane is formed during pyrolysis, it will get released. So the kind of raw material or the kind of products that is generated after pyrolysis, these are rarely in the form of oxidative states like CO2, CO. These amounts are usually less, and these methane reduced forms are usually more, like methane and hydrogen, those stuff. Because in here, most of the energy it goes into breaking these bonds and not oxidizing them. In case if there is somewhere oxygen also present in here, then there is a chance that carbon monoxide and CO2, these can be formed. Am I clear?
Okay, so
Yeah, so that is the main difference, because in combustion there is energy, there is oxygen, so the reaction takes place to form CO2. But in pyrolysis there is energy, but there is no oxidation, oxygen there. So what happens, the energy, it is mostly spent for breaking the internal bonds, and usually it is much lesser than those plasma temperatures, so not all the bonds are broken. Some of the bonds are broken, and those light hydrocarbons which are formed like methane, ethane, alkane, they tend to separate into the gas phase and form the pyrolysis gas, which can have high calorific value. And if your raw material is having some amount of oxygen, sulfur, then such compounds may be formed, like carbon monoxide is often formed, little amount of carbon dioxide can be there, and hydrogen is also often formed. So that is how it works. And if sulfur is there, then different sulfuric compounds can also be present. Okay. So now moving on to the next question, whose answer I think you will be able to say right away. Conceptual composition of for conceptual composition for characterizing the combustion potential of a waste includes FC stands for fixed carbon, VS stands for volatile solids, IN stands for, or I will write it like this, inorganics plus ash plus water. Okay, so out of these four, which one do you think is the correct answer? Okay, yes, option A is the correct answer for this question. Now moving to the next one. Next one is a very easy and simple numerical based question, and I won't be sharing the options with you. What is the oxygen requirement? That is what you need to determine for complete combustion of 100 grams of methane. So that is what you need to calculate. Okay, so I will give you an option, like a hint. We can solve this question stoichiometrically based on the equation of how methane reacts with oxygen to form carbon dioxide and water. Okay, sorry, the Microsoft. I will give you a hint. Like you have to solve this question stoichiometrically based on the chemical equation. How it works is that methane, it reacts with oxygen to form carbon dioxide and water. So based on this balanced chemical equation, you have to calculate the oxygen requirement. You write this chemical equation: CH4 plus O2 is equal to CO2 plus H2O. Then balance the equation if required. Finally, consider the amount of moles, their molar masses, balance them, and then using kind of unitary method, you can calculate the oxygen requirement. So anyone is trying to attempt the question, or should I solve it? You can take about 2 more minutes, then I will solve the question. Okay, so first hint, methane reacts with oxygen to form CO2 plus H2. Then going back to our school day chemistry, we have to balance this equation first. One carbon atom is here, one is here, so carbon is balanced. But if you take a look, there are 4 hydrogen atoms, 2 here, so that is why 2 times H2O, that makes 4, and this balanced. Then 2 is also here, 2 is also, but you see then there are 4 oxygen atoms required. So add a 2 also here. So now this chemical equation is balanced. Now we will, next step is going into their molar masses. So if you take a look, what is the molecular weight of methane? 12 plus 4 atoms of hydrogen, that means 16 grams. Okay, so in below everything I am already dictating it, that in below the masses are in grams, molar masses. So 16 is for methane, and we have for oxygen 32 for one, and since 2 molecules are there, so that will be 64. So 64 grams of oxygen is required for 16 grams of methane, molar, based on the molar masses. Reason being, 1 mole of, this is 1 mole of methane, it requires 2 moles of oxygen, and in below they are their individual molar masses. So based on now considering the masses, it is very simple. Using a unitary method, how much methane will be required now? Sorry, not methane, O2. Oxygen required will be 64 is required when you have 16 grams of methane to burn. Both units are in grams, so they will cancel out each other. And now when you have 100 grams of methane to burn, so multiply with 100. So your answer will be, I guess, 400 grams of oxygen is required. I hope it was clear. If you have any doubt, you can unmute yourselves or you can use the chat box. And now, just as an extension for this question and the easy practice, I would like you to calculate how much carbon dioxide and how much water would have been produced if for the same condition 100 grams of methane has been combusted completely. So amount of CO2 and water generation. Any answers? I would like you to attempt this kind of questions because these questions are very simple and there is high probability that such questions can also be asked in the final examination. And in fact, if you have any question, any queries, please feel free to unmute yourselves at any time. Okay, so I can see 263 is one of the estimates and 225 for water. So we will check it and see what we are getting. 44, so not 44 divided by 16 into 100. Similarly, water pond will be 36 divided by 16 into So CO2, it should be 275, right? Because molecular weight of carbon dioxide is there are two atoms of oxygen, 16 to the 32 plus 12 for carbon, it's 44. So 44 grams of carbon dioxide will be formed after 16 grams of CO2, this methane is combusted. So how much will be formed after 100 grams of methane combustion? So that way I think 275 should be the answer. In case if you have any doubt, I have taken CO2 as 42. Okay, so that is right. It should be 44. 12 for carbon and 16 for individual oxygen. So 16 into 2, 32 for both the oxygens plus 12 for carbon, that is 44. Then you will get the right answer. Fine, so you can try similar questions. Now we will move on to the next one. For this particular one, you can refer to your notes that you might have taken or the class slides that you might have referred to when Professor Dubey was teaching during his sessions or during his NPTEL courses. So the question is, so this is the question. You have to calculate stoichiometrically the amount of oxygen requirement for a material, a biomass having this chemical formula. And for that, I will initially give you a hint that you can refer to the class notes of Professor Dubey. In case if you are not able to find that, please ping in the chat box. I will share the equation with you, and then I hope you will be able to solve it. In the meanwhile, I will share the options. Please let me know if you need help with the formula. If you get the formula, I think you can quickly solve this question. Okay, you can use this formula to calculate the oxygen requirement. The equation has been shared, and I would advise that please solve this question yourself. Like once this equation has been shared now, I don't think there should be any difficulty in solving such easy questions. Based on the question, if you take a look at it, I will again share the question. Here you can see that C, A, H subscript B, O subscript C, and N subscript D. Similarly, in this particular question, this is the chemical formula. This is the molecular formula or molecular structure. So you can identify from here, you can first make a note of it at somewhere in some copy or notebook. C20, H18, O4, and N2. And then we will go back to this particular question. So from this particular equation, what should be A? It should be A is C20, so A is 20. Similarly, HB means our question had H18, so B is 18. Oxygen here is C, and in question oxygen was 4, so in here C is equal to 4. N subscript D, and in question N2 was there, so D is equal to 2. Now please calculate filling all these values here and find out the oxygen requirement. So if you calculate it, which is now very simple and easy, you will get 672 as the correct answer. That is option B. So now I will move on to the next question. So when can you say that the compost has become matured? Your options are okay. So which one do you think is the correct answer? Yes, option A is the correct answer. Now moving to the next question. So I will also see if I have any points for you or not. Okay. So this is from where you could have seen the answer. Like once the compost has become matured, when you in fact turn it over, there won't be any sharp increase in temperature, which we see otherwise when there's still the composting process is undergoing. So that won't occur when you turn the compost or mix it. Secondly, our option, the correct answer was humus like dark brown and earthy smell. And then another option will be, another observation is that the volume of the compost will decrease drastically and almost become half. So these are some of the observations. So now again we will move on to a numerical based question. So the you have to calculate the lignin content for some agricultural waste, and what you have been provided is that MC is moisture content, it is 26%, VS is equal to volatile solids 78%, and BVS is biological volatile solids, it is 59%. So based on these values, you have to calculate the lignin content that will be present in that agricultural waste. Your options are, all the options are in percentages. Since I have percentage here, 6.9. For this question also, there is a small and very simple formula. You can think about it. After that, I will share the formula with you, and then you can finally tell me what the answer is. Okay, so this is the formula. Now I hope you can get the answer. BVS, biological volatile solids, 59% is given, 0.83 is given, minus 0.028. Into LCS lignin content, that is what you need to determine. Move them here around this, and then you can determine the only unknown here. I will advise that these questions are very simple and you should attempt them in the class, even if they look easy. For this particular question, the answer will be 8.6. So moving on to the next one, it is a theoretical based question. So the combination of organic fraction of any biodegradable component that remains behind after it has undergone some treatment, plus the plastic that is present there. Taking both of them together, what are they called? Your options are BVS, that is biological volatile solids, inorganics, residual volatile solids, or fixed solids. Yes, option C is the correct answer. So now moving on to the next question. Let's see if I have any figures here. So which of the following methods is generally used to check suitability of compost to be used as fertilizer? Your options are which of these four options you can go to for determining qualitatively the quality of your or suitability of the compost as a fertilizer. It can be qualitative or quantitative estimate as well. Yes, option 1 is the correct answer. That is the seed germination test. Now moving to the next question. So during windrow composting for aeration, which of the following methods you will be using? Yes, option 2 is the correct answer, regular turning. What is the optimum temperature for the growth of thermophilic anaerobic bacteria? All the values are in obviously in degree centigrade. In this lab, साइदुलू वो इस वाले लैब में बैठते हैं. Yes, so these are your options. So thermophilic anaerobic bacteria, very easy one. Option 3, yes, option 3 is the correct one. So quickly moving to our 12th question for today. Also I have I think few slides on this. Let's see. Yes, in here you can see mesophilic goes for 30 to 38 range and thermophilic 55 to 60. Now you have to guess or answer the C by N ratio during the curing period of composting. Yes, so these are your options. Yes, option 1 is the correct answer. So quickly moving on to the next question. Now, which of the following is used as a bulking agent in composting? Your options are sawdust, food waste, immature compost, or none of the above. Yes, option 1 is the correct answer. Now moving on to question number 14.
So excuse me, I have a question for sawdust.
Yeah,
It was mentioned that for bulking agent maybe 25 of particle is required, but sawdust will be very fine. So how it would be with bulking agent?
come again. So 25 mm less than size and sawdust will be very fine. So how will it act as a bulking agent?
Hmm.
So if you see sawdust, like you can see that it is very light and it occupies a lot of space. So it's like if you see a heap of sawdust by itself, so you can see that it absorbs lots of water. So there are lots of pore in it. So if you see overall, so it kind of adds bulk to a mass, adds volume to something. So that is why it is added as a bulking agent.
Okay.
So moving on to the question number 14. So which of the following composting techniques is generally adopted in industries? So your options are aerated, static, pile composting, windrow. Mechanical or in-vessel composting, or none of the above? Very simple question. Yes, mechanical or in-vessel composting. So now the final question of the day. AD means anaerobic digestion, or SW means solid waste. So what should the alkalinity be? And all these values are in milligram per liter as Ca, calcium carbonate. So here also same units will be there. Okay, so which one do you think is the correct answer? Yes, 1000 to 5000 is the correct answer. Okay, fine. So these were the 15 questions that we had for us today. I will quickly go through all these questions again. In case if you have any doubt, you can ask it. Hmm. Okay, fine. So quickly going through these questions. The first one. Okay, fine. So the first question was, out of these thermal techniques, which one includes superheating of gas to an ionized state? So among these four options, combustion means basically thermally exposing any material in the presence of oxygen. So then combustion takes place, which includes incineration, cogeneration, co-combustion, all those kinds of stuff. Pyrolysis basically means when I am thermally exposing a material, the temperature goes easily above 400, 600, 700, like those ranges it can go. So the material is thermally exposed to such temperatures in the presence of an inert gas to maintain an inert atmosphere, and those gases can be, one of the cheap alternatives is nitrogen, and if you want to go for a better ones, which are although costly, they can be noble gases like helium, argon, and like that. After that comes gasification. So gasification is a partial combustion process. So that is by definition. And gasification can be of various kinds. Like there is CO2 gasification, catalytic gasification, when it depends on the purpose, on the goal of the process. And then comes the plasma arc, where the temperature exceeds above 10,000 degrees centigrade. And what happens in here is that the temperature is so high that the bonds itself, they start breaking and they gets convert, like the bonds to break, they in fact start breaking during pyrolysis gasification also. But in plasma the breakage is 100%, like everything gets ionized. So that is why it is one of the most efficient processes to get rid of any material, but the downsides, it is very, very costly. In here you can see. So now the question is, when do we do these processes? So combustion, like for example, when we segregate our waste, municipal solid waste that is generated, if it has a good appreciable calorific value, the segregated waste which contains plastic, paper, and other high energy value stuff, we can send it to incineration plants or cogeneration plants, or these energy to waste or co-incineration, where they are burnt along, maybe they are burnt standalone or along with any other material to generate heat, because combustion is a exothermic process. Then comes pyrolysis. In pyrolysis, what is, like in combustion, what are the major end products? They are CO2 and water plus heat. And like CO2 plus water plus heat, and there can also be, in case of incomplete combustion, carbon monoxide, and if your material has sulfur and nitrogen, then SOx, that is sulfur oxides, nitrogen oxides, they are also generated. Basically, because it is oxidation, so oxides are generated. Since pyrolysis is an inert, taking place in an inert environment, and some of the major products that are coming out of pyrolysis, three of them, the three phases: solid, liquid, and gas. In solid phase, it is char. In liquid phase, it is pyrolysis oil. In gaseous phase, it can be said pyrolysis gas, or based on its composition, sometimes you can also call it syngas if it has almost CO and hydrogen, carbon monoxide and hydrogen. So depending on the intention of the process, the type of pyrolysis, the amount of this char, oil or gas generated, they can vary significantly. Then comes gasification. The major product of gasification is gas itself, because the name itself means gasification. I'm gasifying it. That is the main goal. After that, there is an aqueous phase also, sometimes that is generated, or oil fraction, depending on the type of gasification. But the char or the solid formation, it is comparatively much less. Then gasification can also be of various kinds. There is supercritical water gasification, CO2 gasification, catalytic gasification. For example, taking the condition of example of supercritical water gasification. So what happens is that these things are done usually for wet raw materials. For example, you can have microalgae, you can have food waste, sewage sludge. So they are sealed in a vessel, then heated to supercritical conditions. That is when the water is having the temperature of at least 373 degrees centigrade and a pressure of at least 220 bars. Under those conditions, water stops acting as a polar solvent and rather it becomes a non-polar one. So these organic materials, their solubility in water, they tend to increase under those conditions. So that is another, and then after that comes plasma. So this was about question number 1. So the next question was, which of the following arrangements is used when we have to do acidogenesis and methanogenesis separately? So the correct answer is two-stage batch anaerobic digestion. Sorry, two-stage anaerobic digestion. So in here, what happens in the first digester, the primary activities that are taking place is hydrolysis and acidogenesis. And in fact, since gas is not mainly formed in those conditions, the dome above those tanks, it is usually fixed. But in tank 2, where the major activity is methanogenesis, it has got a flexible dome so that the gas that is produced, it can be stored above the supernatant and the volume can adjust based on the quantity of gas produced. After that, conceptual composition of waste when we have to look at its combustion potential. Then the correct answer is option 1. That is, we have to look at fixed carbon, volatile solids, inorganics, ash, and water content. Then the next question was, you have to calculate the oxygen requirement and for combustion of methane, complete combustion of methane. So the amount of methane was shared with you in those. This is one of the very important questions that I expect to come in the examination as well, because these are very simple, very basic. Write the chemical equation, balance it, look at how many moles are required for this equation, this reaction to take place, write their molar weights, and then after that calculate the oxygen requirement using unitary method. So 64 grams of oxygen was required to burn 16 grams of methane. So how much will be required to burn 100 grams of methane? Simple as that. Similarly, amount of CO2 44 was produced when 16 grams of methane was burnt. So how much will be produced when 100 grams of it is burnt? So like that. After this, you have to calculate stoichiometrically the quantity of oxygen required for composting a waste having this formula. So these are based on equations that you often need. I don't think you need to memorize most of the time, because ideally these should be given in examination, but in case if it is not the trend, then it's better that at least you practice it multiple times so that if it in case comes, then you can attempt. So using this particular question, you can determine the oxygen demand, and this A, B, C, D, these are basically the subscripts of the molecular formula of the waste. After that, the next question was, which of the following is an indicator of a matured compost? So a matured compost has a humus slug, dark brown and colored compost. Then you have to calculate the total lignin content, and what you were given is moisture content, volatile solids, and BVS. So these two are given only to distract you. If you know this particular formula, you know BVS 59%, so put 0.59 here. Rest everything is given. LC is left, just calculate LC, that is lignin content. These kind of questions, like based on the biochemical or biological composition of a waste, why it is important is that, for example, I am giving you two kind of wastes. One is, I have discussed this similar concept during the starting initial few live sessions as well. Like lignin is basically made of aromatic structures, which are very difficult or comparatively much more difficult for the microbes to act upon and finally break them. So for usually in a material, if I am trying to degrade it biologically, if the lignin content is high, the time to degrade that material will be more, and in the same constant amount of time, if I am comparing with other materials, bacteria will find it more difficult to break these bonds. So the amount of the degradation efficiency will also be lower for a same or constant time. So waste in which cellulose and hemicellulose, that's carbohydrates, these things are more, which don't have these aromatic structures. There, the bacteria and microbes, they find it more easy for the work upon them and degrade them. So that is why it takes less time to achieve the desired level of efficiency, degradation efficiency. So that is why determining the lignin content, having a knowledge of it, is very important prior to taking a decision of how a certain kind of solid waste should be treated. Then comes the combination of organic fraction of a biodegradable components that remains after treatment and along with the plastic waste. What is it called? It is called residual volatile solids, because basically plastics are also composed of monomers. Like plastic, basically a polymer, it is also consists of monomers which are basically volatile solids. They are volatile in nature. Then another point I would like to highlight is that, for example, if you have a material that has got high amount of lignin and you are uh, like you have decided I need to biologically degrade it because other treatment methods they are not feasible for your case. So what will you do? And you know that the bacteria is finding it very difficult to degrade that waste in a certain amount of time. So in those cases, what we do is that we try to pre-treat that waste to break the bonds that are present in lignin, or in case it also breaks the bonds in cellulose and hemicellulose as well. What happens is that you can do a certain degree of pre-treatment, that can be heat treatment, and heat treatment can be pure heat, or if mostly the waste is having moisture content, so we can treat it using there are various methods: steam explosion, light hydrothermal treatment can be there. So these treatments, they basically break the bonds in the macromolecules. And other than that, acid treatment can be there, the alkaline treatment can be there. They all kind of serve similar purposes, breaking the bonds and making it easier for the bacteria or other microbes to work upon the waste material and use it as its substrate to produce the desired end products. So finally, so this question has been already discussed. Then, which of the following methods is generally used to check the suitability of the compost for its use as fertilizer? Answer is very obvious: seed germination test. Then, which of the following aeration methods is most commonly used to aerate compost during winter composting? Answer is regular turning. Then, thermophilic anaerobic bacteria, which range 55 to 60. C is to N ratio during the composting period. How much it should be? It should be less than 25:1. Bulking agent in composting, it is sawdust, because sawdust is effect, even if it is, as someone mentioned, it is less than 25 size, but it is very light material. It occupies a lot of volume, which is basically why it is known as a bulking agent. That is why it is used. Then, which of the following composting techniques is usually used in industries: mechanical or invisible composting? Finally, decide alkalinity level for anaerobic digestion of solid waste, which is 1000 to 5000 milligram per liter as calcium carbonate. That is the answer. So I hope these questions were able to gain some knowledge out of it. In case if you have any doubt, you always feel free to unmute yourselves and discuss them here, or in fact you can also use the chat box. Yes, on biological treatment. Yes, what is the doubt? You can use the chat box or unmute yourself as well, whatever suits. Yes.
ম্যাগনেট হট প্লেটে দুটো জিনিস একসাথে রাখা যায় না, সেজন্য আমি তোরটা রেখেছি, আটা ডাইরেক্ট
তোরটা কি?
আমি চালের সাথে
তোরটা তো গরম করার দরকার নেই না,
চলে এলাম যে হট প্লেটে
হট প্লেটের মধ্যে তখন লাগে যখন একটু কিছু গরম করতে হবে, নাহলে তো ওটা ভালো করে। আমার আজকে আর একটা পেপারও পাবলিশ হয়ে গেছে ওটা নিয়ে, যেটা রাজার সাথে করছিলাম। জাস্ট 5 মিনিট আগে। না না, ওই একটা বাইরের দেশের ওই লোকটা ছিল, ইংল্যান্ডের, ও মেল পাঠিয়েছে, ডক্টর বিনোদ করে কেউ। Okay, sorry for the delay. You can see the question on what is the difference in acidogenesis and acetogenesis. What do they basically convert? Fine. So I will start from the beginning in here. Just new slide. Let's say here. Night alaba. So first thing that takes place during, in fact, during most of the chemical, biological or biochemical activities wherein water is present, it is hydrolysis. So your question was difference between acid dough and acid toe. Okay, fine. So starting from here. So what occurs during hydrolysis? I hope you already know this. That means where water is breaking the bonds which are present inside the macromolecules. Once those macromolecules have been broken down to smaller ones, it is easier for the microbes to further work upon them. And what happens after that is that acidogenesis. So hydrolysis of macromolecules like proteins, they form amino acids, carbohydrates, they form sugars, lipids, they form fatty acids, like that. So these acidogenesis, during this process, the hydrolyzed products, they are mostly converted into volatile fatty acids. These can be acetic acid, butyric acid, propionic acid, such volatile, there are other volatile fatty acids as well. So these are mostly formed during acidogenesis. After that comes acetogenesis. In acetogenesis, acetic acid is the major product that is formed here. So you can try to relate it. That is why it is named as acetogenesis. And after acetogenesis, finally, the acetic acid, it is converted into by methanogens during methanogenesis to methane and all. So now based, for example, like this is how things usually work. Now based on the condition, like if the pH varies here and there can be serious deviations or from the expected results. Why? Because among all these processes, methanogens, these are the most sensitive microbes. They are very, very sensitive to pH variations, temperature variations, or in fact any shock loading as well. So for example, in acetogenesis, acetic acid is forming. In acidogenesis also they are forming. So if the pH is going below your 6.5 and all, so then the methanogens, they can't function properly and the methane yield will reduce. So such kind of issues are often faced, and then the difference in the product and gaseous product, you can see its composition also varies significantly. And what do they basically convert? I hope I was able to answer your question. Hydrolysis is basically macromolecules, fats to fatty acids, proteins to those amino acids, then followed by carbohydrates to sugars, then acidogenesis, that is what forms. Then in acidogenesis, those fatty acid, those amino acids, fatty acids, sugars, they are converted into volatile fatty acids in acidogenesis, and those volatile fatty acids, they are converted mainly to acetic acid in acidogenesis. I hope I was able to answer your question. In case if you have any doubt, you can write it in the chat box. ओह सरो आरो आगे ले ली हम देखे ही नहीं. Okay, for acetogenesis to occur, its constituent should be acetic acid only. No, no. For acetogenesis to occur, the initial materials, the acetic acid is can be there. It can be a very small amount, but it consists of other acids. Acetic, butyric, propionic, such other acids can also be there. And its constituents by, I think you are talking about the end product of acetogenesis. Acetic acid mostly, along with it, I think some other some other end products are also there, but it is mostly acetic acid. That is why its name is acetogenesis. Okay, thank you.